to understand how quantum computing store information and why quantum computing can store more information than our classical computer. So think about our classic computer first. Let's say you have only one bit of information, which is let's say you can store one or zero in this transistor. If this is a transistor, in this transistor you can store one or a zero. Okay, so let's say you have a two transistor. So how many information you can store? So you can store two digit number. Okay, I mean in binary digit. So you can store two binary digit numbers. One is one can be like it can be any things, like it can be 00 or 01 or 10 or 11. So these are the information you can store for the 2 bit. Okay, so you can store only one information at a time. I mean 00 or 01 or 10 or 11. This is the way you can represent. Now what about qubit? What is actually qubit? So qubit is something like that, which has two state. One is up and one is down. So that means in qubit there is also two state. So if you take up state as a 1 and down state as 0, so that means qubit also the similar to the classic computer. So there is no difference between classic computer and the quantum computer, as long as we did not take the superposition in our thought. Okay, let's take a superposition in our thought. So till now what we have understand is that a classic computer is very much equal to our qubit computer until we take the superposition. So what is superposition we will talk about now. So classical computer and quantum computer is similar until we take the superposition in our thoughts. So let's take superposition. So what is actually superposition? Let's think about this as a coin. So it is head or a tail. Okay, so when you flip the coin and when the coin is on fly, that time this coin is on superposition. This coin is on superposition. So what we can say is for this coin is there is a 50% chance. That means you can say 50% chance of getting header and 50% chance of getting tail, right? So for representing this you need two value, right? So we can write this in a way that 50%, let's say header, I mean the chance 50% chance is header and 50% chance is for tail. So we can write this way. So there are two value where we can put the chances. So if we change the chances probability, then we can change this value. So we can take this value as a cat notation. I mean you can take alpha header. Alpha means the probability. You can say square. If we square this value, then we will get the probability. Okay, so and the beta. Okay, so beta is another cat notation for the t. So this is what is the value. So there are two values or represent the qubit. So now when the qubit is in superposition, we can say it can store like one qubit one qubit can store 2 bit of information. How? So how it can store 2 bit of information? For header there is a 50% chance to get let's say head and 50% chance to get a tail, right? So for header we can store 1 bit of information. Okay, for the 50% probability we can store 0 or 1 or one information. It can say one information, and for 50% we can store another information 0 or 1. So there are two information we can store in one qubit. Now think about two qubit, how it's work. So I would like to take it as a two coin. Okay, so let's say in the first coin you flip, then it's come 50% of, I mean the 50% means actually zero point 0.5 of header. Okay, let's say header 50% chance, and there is a zero point 0.5 chance getting tail. Now think about, if we flip another coin here, what would happen? So there is another coin which is also have a 50% chance, 0.5% chance of getting head, and 0.5% chance of getting tail. Now if this both flip together, what will happen? What will be the probability of getting header and tail, head and tail? So in that case, what you can do is you can multiply this with this number to get header header, and this with this to get header and tail, and this with this getting tail and header, and this with this one getting tail and tail. So all will be 25% probability or 0.25. Okay, if I just remove this, then you can say 0.25. So 0.25, and this is also 0.25, this is also 0.25. So we can increase this and decrease this based on our probability, right? So as you can see that for two um, qubit, we can store four different numbers. Okay, so in this way, if we add another let's say a coin here, so it will be multiply again. Okay, it will be multiply again with that, and now the probability will be like 0.25 into again 50%, right? So 0.5. So if you multiply this, you will get another it is like 125, 0.125. So this is the probability. So in this way, it will be increased like header header header, and this way header 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 and tail. So in this way it will increase to 8. So as you can see, we can represent it as a 2 to the power n. So if you increase the n, the number of information you can store will be increased in this way. So this is actually the main way of understanding that how qubit store information. It is basically the full of probability. So based on probability, each probability can store one information. I mean, each probability act as a bit. Okay, I mean as a transistor. So each probability act as a transistor. So each probability can store 0 or 1. Okay, thank you.